Did you know that you can measure the speed of light using your microwave? But before we start the experiment, let's first explain how it all works. Microwaves are a part of electromagnetic spectrum, just as the visible light, but they have a different wavelength. Just as all electromagnetic waves, they have electric and a magnetic field which oscillate. Inside of the microwave, magnetron produces electromagnetic wave which reflects off the metal, creating standing wave, which is a kind of pattern that results from the interference of two waves of the same frequency, amplitude, and wavelength, traveling in opposite directions. Food has water molecules in it. Water is a dipole. When an electric field is applied to water molecules, they start to rotate due to the torque produced on the dipole. They rub against each other, producing friction and heat in the food. Now that we know some of the science behind it, let's start our experiment. We are putting the chocolate in our microwave, but beforehand we took out the rotating part that lays underneath the plate. Time of the chocolate inside the microwave can depend on many factors, but here I took for about 40 seconds. We expect chocolate to melt on hot spots, which are places where so-called antinodes, in other words, maximum wave amplitudes apply. In contrast, other points experience minimum wave amplitude and they are called nodes. After the microwave is done with melting, it is time to measure. We are measuring the distance between two hot spots. The distance that I measured is approximately 6 centimeters. Since lambda is 2 times d, we have to multiply our measurement by 2. We get 12 times 10 to minus 2 meters. Since the speed of any periodic wave is product of its wavelength and frequency, we can write c equals lambda times f. Value of frequency stated at the back of the microwave. The only thing left to do now is to calculate the speed of light. We get the result of c equals 2.94 times 10 to the power of 8 meters per second, which is very close to the real speed of light.